Okay, everybody, come in. Well, welcome everyone. So I'm Saint. I'll be your guide to the universe of Git essentials. Let's say. So hopefully we're ready to explore the unknown. Hopefully we're all hydrated, we're strapped in, buckled up, chin straps adjusted, and hopefully we're ready to. Well, in this analogy, hopefully ready to blast off. So anyway, the reason for me creating this course is I had some feedback from previous lessons that I was going too fast for the absolute beginners, but I was also getting asked for more and more advanced topics. So I decided to create a course that would be a bit more in-depth and slower paced. So I wanted to create a course that would be a good introduction to Git for beginners, but also provide some more value for the more experienced users out there. Now, I've been using Git for several years now, and I found it to be an invaluable tool for managing projects. It's not just a version control system. It's a platform that allows developers to work together, manage their code, and maintain a history of their project. As a developer, mastering Git is not just an option, it's a necessity. It's a skill that will open doors for you and make you more effective and efficient, and an ideal member of any development team. I hear a lot of beginners confused by terms such as staging area and working directory and repository, and I hear a lot of people confused by the differences between a branch and a tag. And I wanted to create a course that would explain these concepts in a clear and easy to understand way. Now, this course will be in two parts. This initial presentation, and then there'll be a part two, which will be a hands-on demonstration of Git. I'll be using Jupyter notebooks for the demonstration part, so you can download them and reference them. But the concepts are at the same time going to be the equivalent, whether or not you're using a terminal or whether or not you're using whatever it is that you tend to interact with Git with. On that note, I would say it's very easy when you first start out to rely on graphical user interfaces and those kind of tools to interact with Git. And while they do speed up the workflow, I would recommend that you at least have the underhood basics of the command line at your disposal, so you can revert back to it whenever you should need. These GUI programs are great, but if you don't really have this underlying fundamental of what's happening on your tool set, you're not really ever going to fully be in control of your Git and your version control. So with that said, I hope you find this course useful, and I hope it makes you become more confident with Git. So let's have a look at the first slide. Okay, so let's have a look at what Git is. So Git is a distributed version control system, and this is sometimes referred to as a DVCS. But what does that actually mean? So in simple terms, a version control system allows us to track and manage changes to our files without overwriting any part of the file. And the distributed part, it really means that instead of having one central place where all the versions are stored, a little bit like Subversion in Parse, if you're familiar with Subversion or SVN, but rather than having one central place where everything is stored, with Git, every developer gets their own local copy or clone, let's say, of the entire repository. So this approach has many advantages, including speed. It actually improves the data integrity and support for non-linear and distributed workflows. And we'll talk a lot about non-linear workflows as the course progresses. But a critical feature of Git is that it allows multiple people to work on a project simultaneously. Imagine you're working on a team project. If we didn't have a tool like Git, we'd have to wait for each person to finish their work before we could start on a project. But with Git, everyone can work on their own sections at their own pace and then merge their changes back into the main project. And even more amazingly, Git intelligently manages these merges. So keeping track of who made what change and also alerting us if there are conflicts between different people's changes. One of the Git fundamental concepts that I'll try and get across in this course is that Git thinks about your data more like a series of snapshots or a miniature file system. And every time we commit or we save the state of our project, it takes a snapshot of what all of our files look like at that moment in time and then it stores references to these snapshots. And to be really efficient, if your file has not changed between commits, what Git's going to do is rather than store the file again, it's just going to link to this previous identical file that's already stored when it creates this snapshot. And this snapshot is literally a snapshot in time of what all your files look like at that commit. So with that in mind, let's start understanding more of the Git architecture. Okay, so as we looked at the last slide, just a reminder, Git is a distributed version control system that allows multiple people to work on a project simultaneously. What I'd like to add to that as well is a lot of beginners, it's quite common to sort of see Git as a sort of super save button for your project. And you might think that Git merely keeps track of the differences between your various file versions. However, this doesn't really actually cover actually what's going on. So you could think of this like a librarian. A librarian might have a catalog of books in the library, and as new books come in, they'll take the catalog index of the books and they'll just add new books to this index. And then the catalog is ever growing. So this catalog is ever expanding, but you're still writing these new records in this book, if that makes sense. Whereas what Git is actually doing is it's saying, okay, well, we've got this catalog of all the books that are in the library right now. When we have additional books come in, so we've had another 10 or 12 books come in, rather than add those 12 books to this ledger or this catalog, instead, we're going to create a new catalog, and this new catalog is going to have the knowledge of all the previous books and also these additional books that we've just had come in. So now we have two catalogs, and we could go back to what the library looked like before those books came in by looking at catalog 1, or we can fast forward back to catalog 2 and see what the library looks like at catalog 2. If we just had that one ledger, that one catalog, and we keep adding to it, then it's going to be very hard for us to keep track of what came in at what time and where. Now, obviously, people could argue that there might be some kind of complexities that could be done with times and dates and all this kind of thing. But the reality is, this is how Git works. It takes a snapshot of the entire library, if that makes sense. So it takes an entire catalog of books and it documents them at each commit. So every time you commit or every time you add a new book to your library, Git is taking a snapshot of the whole thing and it's creating a brand new ledger. So I hope that makes sense. And interestingly enough as well, I've added to the slide, Git was created in 2005 by Linus. So the same genius that gave us Linux. And his aim at that time was to build a version control system that was more efficient and more capable of managing projects than anything that was available at that time. But in summary, think of Git as a sort of ever-watchful collaborator that enables a team of developers to work on a project concurrently, providing each of us with our own full copy of the project. It's distributed in nature, which breaks from the conventional model of centralized version control, and it's basically one of Git's most powerful features, and we'll be delving deeper into its many benefits as we go through this course. Okay, so let's talk about the power of version control. So we can think of as version control as something that keeps track of the changes to the files or even a whole bunch of files over time. And what this actually means is we can go back to any specific version of our work or somebody else's work whenever we need to. So imagine we work on a big project and we wanted to see what that project looked like a week ago. Well, version control would make that possible. But version control is not just about looking back in time, and that's great. It's a great tool for team workers to problem solve. We can keep a detailed log of who made what changes and when. And it's easier to see how your project evolved. We can find out who made a certain change. We can spot when problems first showed up and see how each change affects other parts of the project. This can make it much easier to fix bugs, much easier to optimize code, and also to understand how changes impact our project. And the best part about all of this, really, is Git sort of acts as a safety net for our code. So if you lose files or you make mistakes, version control is there to save us. We can recover lost files and we can undo changes without much hassle. And this will save us lots of time and lots of stress. So in a nutshell, version control is almost like a safety tool for your project. It allows you to try new things. We can take risks without having to worry about that we'll break something beyond repair. For anyone that's sort of getting into Git today, this really is a game changer. And if you're not using Git right now, and instead you're just like adding extension names to files, so file 1, file 2, file 3, file 4, now is your time to change to Git. Git really is a game changer. Okay, and as we look at the practical part of this, you'll see how easy it is to get started. Okay, so we touched upon some of this in previous slides, but in the world of version control systems, Git stands out, and for several reasons. So I hear people often comparing it to other systems like SVN or Mercurial or CVS if you're that old. But there are key differences that set Git apart. So firstly, Git is actually known for its speed and its efficiency. And this is actually one of its design features, which is actually designed to emphasize performance. It handles large projects with ease, and its operations are typically much faster than any of these other version control systems. But secondly, Git supports non-linear development, as I mentioned earlier. And through its robust system of branching and merging, we can develop these non-linear workflows. And this allows developers to work on multiple features or multiple fixes simultaneously without interfering with each other's work. And this is a significant advantage in a team setting where multiple people are working on the same code base. And just to go one step further, I could be working on maybe 3 separate features on 3 separate branches locally, and I could be switching between them using Git, while other people are also working on features on their machines, which affects the same part of the code base. This really does scale greatly. And that goes to my last point, which is Git's distributed nature is its defining characteristic, and other systems have tried to emulate, but unlike these centralized version control systems where there's this single copy in this single central repository or server, Git is distributed. And this means that every developer has a full copy of the project and the history on their local machine. And here's the plus, right? So this does not only allow for full backups of the project for everyone in the team, but it also lets developers work offline, and it gives them lots of flexibility in how they work. You don't have internet, no problem. You can work offline, and when you do get internet access, you can then merge your changes back into the main production. So in summary, Git's speed, its support for non-linear development, and its distributed nature is what actually makes it so powerful for version control. Okay, so let's dive a bit deeper into the Git architecture. So in Git's architecture, we have let's call them 3 main areas or trees that we work with. So the first is the working directory. So this is where you'll be doing all your work. You'll be doing your creating of files, editing, deleting, and even just refactoring and organizing files. This is your personal workspace. The second area is the staging area. So this is like an intermediate area where commits can be formatted and reviewed before completing the commit. So you put your files into staging area, and once you've formulated the exact files that you want to be part of that commit, so I don't want to give you too many specific examples because I want to make this course open to as many people on as many different projects as possible. But maybe you have an index.html file that needs to be paired with a main.css file. And because those 2 files go hand in hand, you might want to stage them for the same commit. So in your staging area, you might add the index.html, and you might add this main.css. You prepare those files, but they might not be all of the files in this working directory. So once we've staged these files and we've decided what we're going to be committing to our Git repository, the third area is the Git repository. So this is where Git stores the metadata and the object database for our project. And this is the most important part of Git. And it's what is copied when you actually clone the repository from another computer. Okay, you're actually cloning the Git repository. You're not cloning the working directory in the staging area. And the Git repository is where the commits are permanently stored. So those three areas, the working directory, the staging area, and the Git repository, these are really the fundamental components of the Git architecture. And understanding how these areas interact is really the key to understanding how Git works. Okay, so let's have a look at the building blocks of Git. This is where things can sometimes be tricky for new people. So I really want to go over this quite slow. So in this world of Git, we have these basic elements of a repository, and we refer to them as Git objects. A little bit like the DNA of our project. These are like essential units that make up this entire system. And we have four primary types. We have blobs, we have trees, we have commits, and we have tags. So let's start with blobs. So picture a blob as containers that store our file data. And each blob is tied to a file, but interestingly, and this is a point I really need to get across, interestingly, it doesn't store any metadata about the file itself. It's like a storage box that holds the contents, but it doesn't label what's inside. And you might wonder, why doesn't Git store file metadata in blobs? But it's this approach that makes Git more efficient and more flexible. So by separating the data from the metadata, Git can easily handle changes and reuse identical content across files and maintain the same file, if you think about it, in different states across multiple branches. So if the file hasn't changed, it's the same blob, it's got the same content, but how Git points to it or references it can be from multiple places. So that's why Git doesn't label things with the metadata. The next thing we need to look at is these trees. So if blobs are the storage boxes, trees would be, in this analogy, like shelves and rooms, really, that organize these boxes. They map the blobs to file names and they store directory names. And this enables Git to recreate the exact structure of our project. So we've talked about blobs, we've talked about trees. Let's talk about commits. So we can think of commits as specific markers on our project's timeline, and each commit points to a tree. And the tree is marking a snapshot of our project at a specific moment in time. So it's like a breadcrumb trail. Every commit links to the parent before it. So the parent commit before it is linked by every commit, and it forms this chain leading all the way back, no matter how far down the project you are, but leading all the way back to the initial commit. So the last piece of this is tags. So we have tags. Tags are like, think of tags like user-friendly bookmarks in our project's timeline. So they're pointers to specific commits, and they usually mark important milestones in our project, such as the release of a new version. So I hope those four constructs are clear, but I understand in these objects and their roles, you're really getting close now to actually understanding how Git is operating under the hood. Okay, so following on from our last slide, let's talk about references. So in the world of Git, references would be more akin to, let's say, signposts. They are essentially pointers to commit. So a little bit how we talked about tags in the previous slide. So They're essentially pointers to commits, really serving as an easy to understand alias. And really that alias is actually for the SHA-1 value that Git uses internally. And we'll be looking at these SHA-1 values when we go into these demonstrations. But there's a few key types of signposts. And one of them, as we talked about before, are tags, and another one is branches. So think of branches as dynamic pointers. They always stay at the top of our progress. They point to the latest commit in a sequence of developments. So when we make a new commit, the branch pointer moves up. Now you might have multiple branches all at different pointers, but the commit in that branch will always be at the tip. So it's always going to be marking the new commit as the latest development when you move to that branch. But in contrast, tags are more like historical markers or bookmarks, like I said before. They are pointers to specific commits, and they usually represent significant moments in the project's timeline, like a software release, we said. So, but then there are also some special references. So we've talked about tags, we've talked about branches, but there's also this head pointer, and you'll see it in all capitals, HEAD. And the head pointer is a unique pointer that always points to the current branch. So it's like a compass needle showing you where your project is currently at. So you might have hundreds of branches in a project, but the head is only going to point to the current branch that's in use, okay? Another point, master used to be the default branch name in Git. When you'd initiate a new repository, a branch named master was created, and that would become the active branch. However, as part of an industry-wide change to use like more inclusive terms, many have transitioned to using main as the default branch name, which in itself is a tag. I should actually update my slide, but technically speaking, master is still the default branch name. But what you'll find is when you start using GitHub and GitLab, etc., for the most part, it has now been changed to main on those platforms. The last reference we have is origin. So this is the default name that Git will assign to the server from which you cloned. So in Git lingo, this is known as remote. So origin is simply the conventional name for the server from where the repository was initially cloned. To fully grasp Git, though, it's essential to understand these references and their roles, and we will be looking at them in more depth as we go through the presentation, as we go through the demonstrations. Okay, so let's have a look at the local to remote Git workflow. So we'll look at this in two parts. So let's understand the local Git workflow first, which is going to be the crux of our daily interaction with Git. And this consists of three fundamental steps. So we've talked about some of these steps before. They are the editing, the staging, and the committing. So editing, this involves us making changes to files in our working directory. We might include writing new code, rectifying bugs, updating documentation. But this working directory, as we talked about before, is our sort of sandbox where we have the freedom to experiment and conceptualize new ideas. And it's our local play environment. Staging is the next step, which comes into play once we're satisfied with the changes that we've made in our working directory. So at this stage, we prepare a snapshot of changes which will be committed to the project's history. They're not actually on the project's history at this moment in time. So when the files are in your working directory and when they're in staging, they're not actually in your project history yet. So in your working directory, you have files that are not in your project history. Staging, you're staging them to be added to the project history. But then that final step is committing. And this is the process of permanently storing your changes in your Git repository. So we do this with the Git command. And the Git command takes all changes from the staging area, it bundles them into a new commit object, and it stores it in the Git repository. A commit object not only contains all the changes, but also includes additional metadata as well, like a timestamp and a commit message. And the commit message serves as a descriptive label detailing what the changes were that were made, and it also facilitates better understanding by other members of your team about what you've done. So those are the 3 steps for the local workflow: the editing, staging, and committing. And then now, once we've done the local workflow, we'll then be looking at how to get this code, or these changes, I should say, rather, pushed to the remote origin. So just before we do that, I just want to just quickly show you those 2 commands. So we're not going to dwell on too much code in this presentation, but I do want things to click when we go from this presentation onto the interactive notebook. So I do want to show you a couple of code snippets about what we just talked about. So here we can see a code example of the commands we discussed in the previous slide. And in that first command, we're using the git add command to add files to our staging area. And then once we're happy and we are ready to push our stages to our repository, we can then commit them using the git commit command. And just as an interesting tidbit, that's an all one-liner command there by using the -m. You can just do git commit without the -m and without the message, but it will be a more interactive experience. So, and we'll talk about that when we go into more code examples. But just for now, just understand that when we're looking at local Git, we are typically, for most of the time, looking at adding files to our staging area and then committing them. Okay, so now moving on to the remote Git workflow. So the remote Git workflow plays a pivotal role in facilitating collaboration on our projects. And it has 2 key actions. It's the pushing and pulling. So pushing refers to the act of transmitting your commits or the changes you've saved in your local repository. And then this action is how you share your progress and updates to your team or the wider community. So in essence, you're pushing, as you push, you're indicating that you've made some changes and that these changes are now ready for others to view and to utilize. Conversely, pulling is the mechanism by which we receive updates from a remote repository. So this is how we integrate modifications by other people into our local version of the project. So by pulling, you're essentially saying, I acknowledge your updates and I'm ready to incorporate them into my local work. The commands git push origin branch and git pull origin branch are your basic tools for pushing your changes to the remote repository and also pulling changes from the remote repository. The branch section of those commands is designated to the specific branch you wish to push or pull from. And we'll look at that when we get into the code. But the nomenclature is going to be git push origin and then your branch name. Now, origin is the default name for the remote, as we talked about before, but it's not necessarily the only name of a remote that you might have. And we'll look at multiple remotes and changing remote names when we look at the code. But the essence of remote workflow lies in this sort of collaboration of pushing and pulling code from our local repository. So by effectively managing this process and being on top of it, we can have more of an insight of when do we want to incorporate code from other people into our project, and also when do we want to push our code to the repository or the remote origin in this case. And these are very, very nuanced questions depending on what we're building and what we're doing. There might be times where you want to push to the remote origin quite often. There's other times where you don't want to push any code up until it's completely ready or it's not ready to be seen, etc. So there's some big decisions that we need to make with this sort of pushing and pulling. Sometimes maybe pulling a change from a remote repository might not be a good idea until you finish what you're doing. Again, this will all come down to the nuances of the actual project and the task. But just know that if we're not using this pushing and pulling mechanism, we are just essentially working in a local folder. And here we can see there's the 2 commands there. So they've got the git push origin, and then that branch name there will get replaced by the branch that we're working with. Okay, so quite often beginner devs, they get an idea of how to initialize a Git repository. They're used to working locally, and they're capable of pushing up to some kind of GitHub or GitLab service. But when you work in a team, you really need to understand the collaborative Git workflows and how that's going to operate across the team. Now, if you're not the team lead, it's always good to talk with the team lead and just make sure that you are aligned with the strategy that the team is using. Don't just go off and do your own thing. But when it does come to collaborating with Git, we've got different models, and different models are suited for different team structures and project scenarios. One sort of common workflow, which is the centralized workflow, is very simple, but it's the process of having all changes directly committed to the master or the main branch. However, I find this model can lead to conflicts, and it requires meticulous conflict management. The second workflow, which is actually the more common workflow that you'll see in teams, is the feature branch workflow. And this is where we create a new feature branch or a new bug fix branch for each individual fix or feature. And then this method, it essentially protects the main code base. So it makes the development of a new feature and the integration process a lot smoother. The Git flow workflow, I've added to this slide. It's very unlikely that you'll be using it. It's a legacy workflow, and it's a lot less common today. It assigns specific roles to different branches and other. It's very, very complex essentially, and it's okay. But with multiple developers, it can get very rigid, and for some teams, it's just too much. So I've included it there, but just know it's a very legacy workflow. The forking workflow, though, is perhaps most familiar to developers who use platforms like GitHub or GitLab. In this model, each developer gets their own server-side repository, fostering an extremely flexible environment. Now, the changes are made in this personal copy, and then a pull request is created to merge these changes into the main repository. So this model encourages open source contributions. It fosters a more collaborative coding environment, and anyone can come in really in the forking model. In the forking workflow, and they can make changes and then offer their changes back with a pull request. You'll also see some teams have multiple repositories for maybe tests in production, staging area, etc. And sometimes you also get a very similar approach where rather than doing the feature branch method, they will actually do forking and pull in workflows. Again, this is all dependent on the workflow that your team leader has set out, or if you are now becoming the team leader, this is something that you will have to sit down and really work out what is the best workflow for your project. Does it involve forking off and maybe developing locally and then offering pull requests back? Do you feel like you might need feature branches and bug fix branches that you merge back into the main branch? Or do you want a combination of methods? As I said, I wouldn't recommend the centralized workflow unless you're working by yourself. But if you're working in a team, I typically use a combination of the feature branch workflow and then sometimes the forking workflow. So hopefully that makes a little bit more sense. And I will go into more workflows in later videos. Okay, let's have a little talk about branching and merging, which is really the heart of Git, and it's essential in order to bring your changes into the main production branch. And it can also be a topic that can be quite confusing for beginners at first. So let's break this down. So as I said, branching is a key feature of Git. It allows you to create a separate line of development within your project, effectively isolating your work from the main version of the project, even within your own workspace. So this means you can explore new ideas, develop features or fix bugs, knowing that your changes won't impact the main project unless you decide to merge them. And creating a branch is so straightforward. There there is no limit to the number. Well, I guess there is an upper limit theoretically, but there's no limit really in a realistic level of how many branches you can create on your local system. You can have a different branch for each different piece of work that you want to be doing. You could even have a branch for each attempt at solving a problem. Branches are really, really versatile. But remember, creating a branch doesn't automatically switch to it. And I see this mistake not as often actually as I'm probably making out, but I do see this mistake sometimes. So when we create a branch, we have to switch to our branch. And to do so, we normally use something like the git checkout command or the git switch command, but the git checkout command. And then this command updates our project files to reflect the version of the branch which we have shifted to. Once we've done with a branch, perhaps we've merged it, but it's changes and now be merged back into main, say, and we don't need it anymore, we can also delete branches. So it's very, very easy to delete branches. And I've got an example there on the slide of using git branch with the -d. We'll talk about that command in more depth because there is a variation of deleting a branch with the capital D, and we'll come to that. But keep in mind, you can't delete a branch while you're on it. You have to switch to a different branch first. And if you do try to delete a branch that is not merged and you're using the git branch with the -d, you will get a warning on the terminal and you won't be able to continue. If you use the capital D, you'll get told on the terminal you haven't merged this branch in, but it will force the delete, assuming that you're not on that branch. So I hope that makes sense, and we will look at this more when we look at the code. And here we can see there, we've got the first command. So we've got the git branch command, basically creating a branch. We've got the second command there, the git checkout branch, and that could also equally be git switch branch. Both commands work, and we'll come on to why there's multiple commands. But the git checkout command will then switch to that branch. Once we're done with that branch, assuming that we're not on it, so we'd have to do a git switch or a git checkout again back to a different branch, but we can then delete that branch with the git branch -d. And then, as I said, if it's a lowercase d, we'll get a error if we haven't actually merged our code. But if we have merged our code, the branch will be deleted. If we use the capital D, we'll get notified that we haven't merged, but it will just delete the branch and it'll be gone. So let's just take a moment here to talk about merging. So we just talked about branches. Let's now talk about merging. And merging is a central mechanism in Git that allows you to combine the work done in different branches. So essentially it takes the content of a source branch and then it incorporates it into a target branch. So imagine two branches, each representing two different trains of thought or work streams. Merging is the act of bringing those two together into a single project or a single file or however you want to think of it. But here's how it works. So first, we need to switch to the target branch. That's the branch that we want to merge into. So we might do a git switch main or a git checkout main. And then we'll do a git merge command. So once we're in that target branch, we'll do a git merge command and then the source of the branch that we want to merge in. And what we're doing there is we're incorporating all of the changes from that branch and we're merging it into our main branch. So one of Git's powerful features is its ability to automatically merge. So we can actually have Git automatically merge the changes from the source branch into the target branch, provided that the branches have been diverged in a straightforward manner. Now, there can be times, I'll repeat, there can be times and instances where Git can't automatically determine how to integrate the changes. When these happen, this is what's called a merge conflict. And I'm going to discuss this in the next section, but this is nothing to be alarmed about. This can be a common occurrence in Git workflows. Sometimes it can be a little bit annoying when Git can't automatically merge, but you have to remember if two people are working on the same file, especially around the same lines, it can be very, very hard for Git to apply any intelligence in the merging. So It will be something that you'll have to do from time to time, and there are tools, and we'll talk about them later in the series. But for now, just understand that if two people work on the same file and Git can't actually determine how best to merge these branches, there is going to be a conflict. So, and you can see here, I'll just put a quick, just again, we're not looking at too much code during this session. We will be in the next. But you can see here, I'm just switching to the target branch and I'm merging in the source branch or whatever I want to merge in. So I could be doing a Git checkout to the main or dev or testing, wherever that branch is. And I might do a Git merge feature branch 1 or something. Obviously, your branches should be well named, and we'll talk about that when we get into the naming. Okay, so just to go into that last point a little bit more into depth. So merge conflicts in Git, very similar to two people kind of talk at once, I guess. So someone has to yield. You can't both talk at once. So someone has to come first and someone has to come second. This usually happens when there's two branches, you're trying to merge them in, and the two different branches have changes to the same line of code in one or several of the files. And then those branches, when they're merged, Git just doesn't know what to do and what it should keep. So then it requires you to intervene and decide. And that's usually the second person in that conversation. So the first person has made some changes to their code. You then try to merge them in. And then when you do, you might then have that person change a line of code that you've also changed. And then you have to resolve that conflict. When this happens, and this issue happens during a merge, it marks the problem area in the file with what we call conflict markers. And then these markers, they look a little bit like arrows or chevrons, and they fence the conflicting changes, and they show you what's different between the two branches. And it's your job to choose what stays and what goes. Maybe you keep the changes from one branch and discard the other, or perhaps you decide to blend the two changes together. Once you've made your decision, though, you manually edit the file to implement it, remove these conflict markers that you'll see in your file, and we'll look at this later on. And then when the conflict is resolved, you let Git know by staging the file with git add, and then you can proceed with your commit, finalizing then that merge. Now, remember, resolving merge conflicts can seem challenging initially, but like many things, it gets easier with practice, plus there are also plenty of tools available that can make this task a lot more straightforward, and it is part of the Git process. So just because you've had a merge conflict, don't panic and don't think that something has gone wrong. Okay, I don't want to talk too much in depth about merging and rebasing, but I just want to just point out that there is multiple methods of merging, and there is various strategies. I just want to quickly talk about a very, very simple merge, which is the fast forward merge, because it's probably the most likely one that you're going to see if you're working by yourself. The fast forward merge is probably actually the most common as well. So this type of merge occurs when you're trying to merge a branch into another, and there have been no new commits on that current branch since the branch was created. So in a fast forward merge, Git doesn't need to create a new commit to store the merge. Instead, it simply fast forwards, hence the name, the pointer of the current branch to point to the latest commit of the branch that's being merged. So let me just give you an example. So if we have a branch named feature that we branched off from main, and then we've committed some changes to feature, but the main branch hasn't changed in the meantime, when we merge feature back into main, Git's just going to perform this fast forward merge, and it's just going to adjust that pointer. So remember, a fast forward merge is the simplest kind of merge Git can do. It's clean, simple, and preserves a linear history, which can be quite easy to follow. But there are other merging strategies, and there are other, and there's also rebasing and stuff like this that we will come to later on. But just for now, understand that when you do a merge and you see this fast forward being displayed on the terminal, this is what's happening. So let's just move on to the final section to wrap this up before we go to the code. Okay, so I just want to wrap this section up and just go over a summary of everything that we talked about before we jump into the interactive notebook. So today we've journeyed through quite a considerable amount of the landscape of Git. Started from its core concepts, and we sort of ventured into a little bit more of the advanced functionalities. We uncovered the significance of Git as a distributed as opposed to a centralized version control system. And we highlighted some of its diverse features, from its support for nonlinear development to its ability to manage very large projects efficiently. We also navigated through the architecture of Git. We understood some of the roles of the working directory, staging area, and the Git repository. We learned about the anatomy of Git, diving into the world of Git objects, and we looked to references. And furthermore, we explored the critical aspects of Git workflow, both locally and in a team environment. We uncovered how to use Git to facilitate collaboration and how to effectively use branch and merging strategies. So moving forward, where do we go from here? So where I would go from here is, obviously we're going to look at the interactive notebooks in the next lesson, and we are going to continue to advance these topics. However, if you've got a hunger right now to start going off and learning these things yourself, or you just want to get a bit ahead before we start watching some of the concepts in future videos, then where I would go is, I would actually, the first thing I would do is I'd probably go for the Pro Git book. There's a guy called Scott who wrote a book called Pro Git, and it's actually free. It's available online. So if you go to, in fact, what I would actually do to save giving you URLs, if you just go to Google or Bing or whatever the search engine of your choice is, and just type in Pro Git book, or just even Pro Git, it's very likely to come up as the first result. And again, it is free and it's very good. I also like the Atlassian documentation as well. I find it quite easy to read. So those are the two areas that I would go to. The Pro Git book is actually hosted on the one of the Git documentation websites as well. So you also got the official Git documentation if you so wish. Okay, so final thoughts. So really, Git is an essential game changer if you are a developer, or you are looking to become a developer and you're going to work in the industry as a developer. Git mastery it's like any craft, it's born out of practice and perseverance. It can be very easy to get started with Git, but Git mastery at the top end can take a lot of practice and perseverance. Now, we've actually talked about 80% of the stuff that you're commonly, probably even more than that. I dare say 90% of the stuff that we've talked about already will be your bread and butter when dealing with Git. But there are some very advanced things that we will go into, such as like rebasing, for example, and cherry picking and stuff later on. But the main thing is to remember, and this is like I always try to tell the graduates I teach, but remember, every expert was once a beginner who just kept trying. The path to learning Git might be riddled with challenges, but every time you overcome a challenge, it just gets you that much. It's like when you learn to code, just going through that whole problem solving of just working out where your code's going wrong. You just can't replace that with just instructional videos. And I don't mind if it's YouTube, LinkedIn Learning, whatever your source of learning is. You really do need to play around with this, actually, either in an interactive notebook that I give you or the terminal. But again, Git is free. You can just download it, install it on your local machine, and just play around with it. And I encourage you to do that. So don't stop here. Keep experimenting with Git. Try and push your boundaries. And remember, mastery in Git isn't just about memorizing commands. You need to understand the concept and the philosophy behind it. And there you have it. That's a wrap. We navigated the twists and turns of the Git essentials, and hopefully we have all emerged richer in knowledge. So feel free to loosen your chin strap. And if anyone has any questions or feedback, please leave them in the comments below. I was your guide to the subject, Saint. I hope you enjoyed this journey. That was my time, and thanks for yours. Oh, and if you're watching the channel and you're not subscribed yet, then what are you waiting for? hit that subscribe button and the bell icon to be notified of future videos and all that good stuff. Peace.